Example 23 is a particularly challenging limiting excess question, sort of the peak challenge you'd get in a prelim or HSC question on limiting excess calculations. And in this question we've got 60 grams of copper nitrate dissolved in 2,000 mils of water, and that solution was then added to 1,000 mils of 0.4 mole per liter sodium hydroxide. Now I recommend you read the question first fully, down to G, so to give you some clues. First we've got to calculate the chemical equation, what's in excess, what's limiting, the mass of copper hydroxide precipitate produced, and the concentration of these four ions in solution. So the first thing, present a chemical equation for the reaction. Now we haven't seen this sort of equation before, not in prelim chemistry anyway, and you might have to use some thinking. Okay, it tells you the copper nitrate was dissolved, it was a solution of sodium hydroxide, and a copper hydroxide precipitate was produced. So use some logic based on the question, use your cross method to get your formulas right, balance, and don't forget states because it actually asks you for the chemical equation. So pause the video now, have a go at writing that equation down. Okay, first of all, copper nitrate. Now they didn't tell us which valency it was, but copper is a transition metal. If you're not told the valency, you assume it's 2, therefore it's CuNO32. And that's reacting with sodium hydroxide, which we know is NaOH based on the cross method. Now it's forming a copper hydroxide precipitate, which is copper 2 hydroxide. We're starting with copper 2 nitrate, because it didn't tell us the valency. It must also be copper 2 hydroxide being produced, therefore CuOH2. And if you're producing copper hydroxide, the only things left that the other chemical could be are sodium nitrate, because the sodium hasn't reacted so far and the nitrate hasn't reacted so far. So copper 2 nitrate reacts with sodium hydroxide, produce copper 2 hydroxide and sodium nitrate. But this is not balanced. Let's go ahead and balance that. Hopefully you've got 2 sodium hydroxides and 2 sodium nitrates were required to balance that equation. And last but not least, states. Now, the copper nitrate and sodium hydroxide must be aqueous because they're both dissolved. The copper nitrate was dissolved and the sodium hydroxide was in solution, so they're both aqueous. It told us though the copper hydroxide formed a precipitate, and a precipitate's a solid that forms when 2 solutions react, so therefore it has to be solid, and the sodium nitrate is aqueous. All nitrate ions and all sodium chemicals are always soluble in water. So there's our chemical equation, and the ratio here is 1 to 2 to 1 to 2. So the next step, excess and limiting. So what data have we been given? We've been told we've got 60 grams of copper nitrate. We know the molar mass of copper nitrate is 63.55. There are 2 lots of nitrogen and 6 lots of oxygen. Therefore the molar mass of copper nitrate is 187.57 grams per mole. Moles equals mass of a molar mass. So we can calculate the moles of copper nitrate as 0.32 moles. The next thing is how many moles of sodium hydroxide have we got? Well, we've been given the concentration, which is 0.4 moles per litre. We've been given the volume, which is 1,000 mils, but don't forget in chemistry we use litres as our unit, and therefore that's 1 litre. So number of moles equals concentration times volume, which is 0.4 times 1. We've got 0.4 moles of sodium hydroxide. I've put a little A here though next to the copper nitrate. That wasn't 0.32, that was a long decimal. So I'll save that into A in my memory because I'm going to need that number later on. But the question didn't ask us to find moles of each. The question asked us to which one's in excess, which one's limiting. So I've got to look at the equation. I've got to think what number of moles of copper nitrate is required to completely react that 0.4 moles of sodium hydroxide. So from the ratio, number of moles of copper nitrate on 1 must equal number of moles of sodium hydroxide on 2 if they're going to be in the exact stoichiometric ratio. And so therefore the number of moles of copper hydroxide, the copper nitrate required to completely react the 0.4 moles of sodium hydroxide is just 0.4 divided by 2, gives me 0.2 moles. So to completely react 0.4 moles of sodium hydroxide, I need 0.2 moles of copper nitrate, but I've previously calculated I've got 0.32 moles of copper nitrate. And what that means is there's 0.32 moles available, therefore copper nitrate's in excess, and that means that sodium hydroxide must be the limiting reagent. That means the copper nitrate will still be there when the sodium hydroxide run out. That's limiting, and that's excess. Now we move on to part C, calculate the mass of the copper hydroxide precipitate produced. Well, we know the reaction stops when the limiting reagent's being consumed. What that means is the copper hydroxide, this stops being produced when the sodium hydroxide runs out, because that's our limiting reagent. So that means the amount of copper hydroxide is limited by the amount of sodium hydroxide, and thus we use the mole ratio to figure out how much copper hydroxide has been produced based on the moles of sodium hydroxide, because that's our limiting reagent. So what we can say is the moles of sodium hydroxide on 2 equals the moles of copper hydroxide divided by 1, or just the moles of copper hydroxide is equal to 0.4, which was the moles of sodium hydroxide, divided by 2. We're going to produce 0.2 moles of this copper hydroxide, but the question said what's the mass of copper hydroxide. So once again, mass equals number of moles times molar mass. With molar mass of copper hydroxide is going to be the mass of copper plus 2 lots of the mass of oxygen plus 2 lots of the mass of hydrogen. Our molar mass is 97.566, and therefore the mass of copper hydroxide produced is just number of moles times the molar mass. It turns out to be 19.5, but looking at the data here, all our numbers here are one significant figure, and therefore that's going to be one significant figure as well. 20 grams of copper hydroxide produced to one significant figure. Now I'm just going to clear that now because we need some more space to answer these last 4 questions, D, E, F and G. And I'm just going to bring across the key data from the previous A, B and C. First of all, we need the fully balanced chemical equation with the mole ratio. We need to know how many moles of copper nitrate and sodium hydroxide we have, and the fact that sodium hydroxide is limiting and copper nitrate is in excess. And that 0.2 moles of the copper hydroxide is produced, and also in part where we figured out that to react the 0.4 moles of sodium hydroxide, we only needed 0.2 moles of copper nitrate to react. So that's the information we need from the first part of the question. But looking at this second part of the question, we'll see that all these questions are asking for the concentration of a certain ion in solution. And because we're talking about concentrations of ions, we need to consider the ionic equation. So we're going to break this equation down into its full ionic equation form. So there's a chance to pause the video and break that equation down for practice. Hopefully what you found was that if you break it down, the copper and nitrate turn into copper ions and 2 nitrate ions. The sodium hydroxides, 2 sodium hydroxides produce 2 sodium ions and 2 hydroxide ions. And then the copper hydroxide though, it stays together. It's a solid precipitate. It's not broken up into the ionic form in the water, so it stays as copper hydroxide solid. But the sodium nitrate being aqueous is broken up into 2 sodium ions and 2 nitrate ions. Now looking at this, we can figure out the net ionic equation. Clearly the nitrates and sodiums appear on both sides. They're not taking part in the reaction. So the net ionic equation is just copper ions, or copper 2 plus ions react with 2 hydroxide ions to produce copper hydroxide. And that's a 1 to 2 to 1 ratio. And the sodium and nitrate are our spectator ions. And that means because they're spectator ions, their number of moles doesn't change. Because they're not reacting, however many moles of sodium and nitrate we started with are the same as the moles of sodium and nitrate we finished with. So now we can put a little table together to find their concentration in the final solution. Once again, the species, how many moles did we start with, how many reacted, and how many in the final solution. So our species are copper ions, nitrate ions, sodium ions, and hydroxide ions. To start with, well, let's think about what happens if we've already calculated the moles of copper nitrate and sodium hydroxide, but how does that convert to ions? Well, copper nitrate breaks down into 1 copper ion and 2 nitrate ions. That's 1 to 1 to 2, whereas sodium hydroxide breaks down to 1 sodium ion and 1 hydroxide ion. So that means for every 1 mole of copper nitrate, we get 1 mole of copper, and we actually get 2 moles of nitrate. So how many moles of copper do we start with? Well, the moles of copper is just the same as the moles of copper nitrate, which is that 0.32 we calculated previously. Next step though, nitrate, we get twice as many nitrate ions as we had copper nitrate, so we've got 0.64 moles of nitrate. Now don't forget, we saved that 0.32 in our A in the calculator, so here, 2 times that A number, I've saved that as B as well, just in case I need that number later on. For sodium, it's just a 1-to-1 ratio between sodium hydroxide, sodium and hydroxide, so the moles of sodium is just the same as the moles of sodium hydroxide, 0.4, and that's the same for the hydroxide ions as well. Next thing is how many reacted? Well, the copper reacts with the hydroxide ions in a 1 to 2 ratio, and we knew from the previous question that the sodium hydroxide is a limiting reagent, which means the hydroxide ions from that sodium hydroxide are also limiting reagents, and therefore the moles of copper is just half the moles of hydroxide, so 0.4 divided by 2 tells me that 0.2 moles of copper is going to react. No moles of the nitrate and sodium react because they're spectator ions, and because the hydroxide is a limiting reagent, that means all 0.4 moles we started with must react because it's limiting. So our final moles, which is going to be the starting moles, take away the reacting moles. In our ionic equation, we're not actually producing any ions. All the ions are there, so nothing's being produced. So how many moles of copper we got left? It's 0.32 take away 0.2, which gives me 0.12. Once again, saved in my calculator as C. For the spectator ions, it's just however many we started with because we're reacting none, so it's just 0.64 and 0.4. And for our sodium hydroxide, our limiting reagent, it's 0.4 take away 0.4. There are no moles left in solution. All the hydroxide ions are trapped inside the copper hydroxide precipitate. But the question asks for the concentrations. That's our last step. What's the concentration? Well, concentration is moles divided by volume. We can't forget we've actually got a big volume. We've mixed 2,000 mils with 1,000 mils. The total volume these ions are dissolved in is going to be 3 litres. And note, all these numbers are to one significant figure. So here we go. Copper ions. Moles divided by volume gives me 0.04 moles per litre. For the nitrate, 0.64 divided by 3 gives me 0.2 moles per litre. The sodium ions, 0.4 divided by 3 gives me 0.1 mole per litre. And the hydroxide ions, there are none, therefore its concentration is 0 moles per litre. And that's the end of our challenging limiting excess question.